So in the previous video we had solved a similar problem, okay, in which I had told you how to calculate the infiltration capacities. I had told you how to calculate the average rate of infiltration for any given durations, and though in the problem they had not asked us to generate an infiltration equation, we had generated a Horton's infiltration equation or an exponential equation in that problem. So there is another question which has been asked in one of the question paper where they tell you to fit a infiltration capacity curve by the given data. Okay, so let me read this question briefly. So the rate of infiltration from the beginning of a storm are given below. Fit an infiltration capacity curve of the exponential form. You know what infiltration capacity curve is, and if they mention you exponential equation, it is similar to that of Horton's equation. Horton's have given you the exponential equation itself. Okay, now what is the data that is given to you? He has given you the time in terms of minute, and he has also given you rate of infiltration in terms of mm per hour. Okay, so the rate of infiltration in terms of mm per hour and the time is in terms of minute. Okay, so we need to convert this time in terms of hours. Okay, anyhow we can do that later when we are solving that equation. I'll show you that that Excel sheet where I have solved. Okay, now you can clearly see that I have solved this infiltration equation. This is what my infiltration equation is, which is Ft is equals to 8 plus of 312.75 e raised to minus 0.3044 times of t. Okay, we all know these basics of how to calculate this, but I'm going to briefly explain it again so that you can understand how again this has been solved. Okay, now we had this equation, all of you remember I guess. Ft is equals to Fc plus of F0 minus Fc into e raised to minus kt. So in the right hand side we'll bring the Fc to this side. This is what the equation becomes. So I told you earlier that infiltration curve is a non-linear curve, so we want to convert this into a linear equation. So to convert the linear equation, what we do is we'll apply the log on both the side. After applying the log on both the side, this equation will be in terms of linear equation. So what is the linear equation? Y is equals to mx plus c, in which y is log of ft minus fc and x is t and m is minus k and c is log of f0 minus fc. Okay, we all knew this, we had discussed about this earlier also. Okay, right, so this is the value data that is given to you. Time is given to you, rate of infiltration is given to you, time is given in terms of minutes. Okay, and the rate of infiltration is given in terms of mm per hour. Okay, right, so let us first calculate the time. Let us first calculate this y. What is y? Y is equals to log of ft minus ft. Fc is the rate of infiltration, Fc is the constant rate of infiltration. Now let us look into this data. In this data we'll see the point from where the infiltration is remaining constant. So it means what? From time 0 to 10 the infiltration rate was reducing. In the initial stage it was around 600, it got reduced to 8. After 210 minutes you can see that at 240 minutes also the rate of infiltration was remaining constant, which was 8. So from this available data I can conclude that Fc is equals to 8 mm per hour. Okay, so once you calculate Fc, what is the next step? Next step is to calculate Ft minus Fc. Okay, so I have calculated what is log of Ft minus Fc in this column. Okay, so I'll just double click over here so that you can see. So log of 10 qt is representing this log this value which is infiltration rate. Okay, at any given time, minus of 8 is representing the Fc. Okay, so this table will give you log of Ft minus Fc values. So I calculated all of them. Next thing is to draw the duration, time. Okay, so now the time that was given to you in this was in terms of minute. I have calculated that in terms of hour by dividing it by 60. Okay, I have divided all these values by 60. I got to know what is the time in terms of hour. Now I'll draw the chart which is representing me the linear curve. Okay, so let me show you again. So these are my data points. So these are my data points. I have plotted them on the curve. Then I have drawn the best fitting straight line. Okay, the same thing you have to do in your graph also. By these values, your log of ft minus fc should be on the y-axis and t should be on the x-axis, and you have to plot the points. Okay, and then you have to draw the best fitting line for that plot. Okay, so after drawing the best fitting straight line, I got to know what is my equation was. My equation was this: y is equals to minus of 0.3044x plus of 2.4952. Okay, so this is my linear equation. So you know, according to this equation, this y is equals to log of ft minus fc. Okay, now log of f naught minus fc is your constant. The constant is 2.4952. Okay, so we know how much is log of f naught minus fc. So log of f naught minus fc is 2.4952. okay, I have generated from the curve. Okay, from this best fitting straight line. Okay, now how do you solve this? How do you solve this in your graph sheet? So in the graph sheet, wherever this point reaches, okay, over here, so you can determine how much is your f naught minus fc value. Okay, from this line. Okay, if you find out what is the slope of this line, you can determine how much is the m value. Okay, so I have determined the k value also. As you can see, k is equals to 0.3044, which I have got from the curve. You can also determine what is the slope of the curve of this best fitting straight line, and then you can determine what is the k value. Okay, k value has been established. Log of f naught minus fc is determined. Okay, so apply anti-log to this and you calculate how much is f naught minus fc, which is 312.75 I got. Okay, so from this you can again calculate what is f naught. Okay, substituting the value of f naught, fc and k value in this equation, we can generate what is the Horton's equation or exponential equation, which was asked in your question. Okay, so this is another example that I have solved in order to explain you how to calculate the exponential equations for infiltration capacity. Okay, I hope this is very much clear to you. Okay, if you have any doubt in solving this, you can ask me the question. Okay, next is, let us solve another problem for phi index. Okay, I have solved two problems for infiltration, Horton's infiltration equations, how to develop the Horton's infiltration equation. Okay, so if you find any other problem which is interesting and on the Horton's equation, you can ask me. I'll solve it in this in the coming videos. Okay, anyhow, this is another problem. This problem is based on phi index. We need to determine what is the phi index. Okay, let me read out the question for you, and then we'll look into the Excel sheet how I have drawn the conclusions. Okay, so as you can see, the question: a 6 hours storm produced rainfall intensities of 7, 18, 25, 12, 10 and 3 mm per hour in successive 1 hour intervals over a basin of 80 square kilometer. The resulting runoff is observed as 2640 hectares meters. Determine phi index for the basin. Okay, so this is what your question is. Okay, now you can see the data that is given to you. Okay, actually this much was your question. Okay, I have just written it in terms of table format. Okay, so what is the total duration? Total duration is 6 hours. So 6 hours of rainfall is there. Then at every hour, intensities are given to you. First hour intensity is 7, second 18, 25, like that. The values are given to you. 6 intensities are there for 6 hours. Okay, now you know how much is the area of the basin. Area of the basin is how much? 800 square kilometer. The resulting runoff is given in terms of hectares meters. Okay, I will convert this in terms of meter cube also. Okay, later we'll convert this in terms of meter cube. Right now this is in terms of volume itself. The volume of runoff is 2640 hectares meters. Now what we need to determine is phi index for the basin. Okay, now let us look into the Excel sheet so that we can solve the problem. Okay, all right. Okay, I hope this is visible to you now. Now this is the area where I have solved my problem. You can see only this much area. Okay, anyhow, you can see that this is the time and this is the rainfall. Okay, this is the time and rainfall intensity which was given to you in the question. Okay, now the runoff is given to you, which is 264 hectare meters. Okay, 2640 hectares meters, and area of the catchment is 800 square kilometer. From this I can calculate how much is my runoff depth. Okay, so I'll just show you how I calculated the runoff depth in the equation over here. You can see this, I have formulated the equation. What we need to do is that I have to divide the volume by area. Okay, as you can clearly see, the units of volume and area are not same. The unit of volume is not in terms of meter cube and area is not in terms of meter square. So henceforth I have to convert the volume in terms of meter cube and I have to convert the area in terms of meter square or square meters. Okay, so to do that, your runoff depth can be calculated by volume by area. So volume will be in the numerator and depth will be area will be in the denominator. So first you can look into this formula which you can clearly see. So what I have done is that this volume is being multiplied by 10 raised to 4. Okay, so when I multiply this cell, which is 2640 value, multiplied by 10 raised to 4 will give me in terms of meter cube. So first numerator has been converted in terms of meter cube. Next divided by denominator. Denominator is in terms of square kilometer, right? So I have to multiply 1000 square over here. So this denominator value is been multiplied by 1000 square. Now whatever the runoff depth I get is in terms of meter, but I want to determine what is runoff depth in terms of mm. Okay, because my rainfall intensity is also in terms of mm, so I want to determine the runoff depth in terms of mm. So henceforth this whole equation was multiplied by 1000. Okay, so from this I determined how much is runoff depth, which is 33 mm of runoff. Okay, so now I have time, rainfall intensity, I know how much is runoff depth. Okay, so once I know all of these values, what I do is that I first draw the hydrograph just to make sure that you understand the representation. So this is my hydrograph which I have drawn. Okay, now let us calculate the first trial of phi index. How to calculate the first trial of phi index? I hope you all know how to determine the phi index. P minus R divided by time will give you the phi index. Okay, right. So you can see that I have added all these cells. All these cells are representing the rainfall intensities. Okay, in terms of mm per hour. Okay, right now they are given in terms of mm per hour, so it is well enough. Okay, it is good enough. But if it was given in terms of mm per minute, you should have converted all these intensity values in terms of mm per hour itself. Okay, if this duration was in terms of seconds or minutes, you should have converted this in terms of hours. You have to make sure that the units remain same. If the intensity is in terms of mm per hour, your time should be also in terms of mm per hour itself. Okay, then the time interval, as you can see, it is evenly distributed. The intervals are 1 hours itself, so that's why there is no much confusion. Okay, so now let us calculate what is the rainfall between time 1 in first 1 hour. What is the total rainfall that has happened in first 1 hour? It is 1 mm per hour multiplied by 1. It means what? 7 mm per hour multiplied by 1, which is 7 mm itself. So in the first 1 hour, the total rainfall that has happened is equals to 7. Okay, now going to next. So in the second hour or in the second interval, so which is 1 hour, in that second hour we have rainfall intensity of 18, right? So that's why 18 is the total depth of rainfall that has happened in the second hour. Similarly, we can calculate for all of this. So if I take the sum of all of this, 7 plus 18 plus 25 plus 12 plus 10 plus 3, it will give me the total rainfall that has happened in the 6 hours. Okay, that is what I did. I have added all the rainfalls. Okay, next, now this gives you the total precipitation that has happened. Okay, you can see this bracket. So within this bracket, all this value, the sum of all these cells will give you the total rainfall that has happened minus of E41. What is E41? E41 is nothing but the runoff depth. So the total rainfall depth minus of runoff depth divided by 6 will give you the phi index. Will give you the phi index value. Okay. So in the first trial, I got to know that my phi index is 7 mm per hour. Now you should not stop at this point. Okay. There is a little the little change that you have to do in order to calculate the exact value of phi index. So your now what I'll do is I'll verify with the hydrograph. Okay, this is the phi index which I got, which is 7 mm per hour. Now I'll look into all these bars. Okay, all these bars, intensities. You can see that this phi index, if I draw it a horizontal line, it will be somewhere here. Okay. Now you can see that the infiltration value will be 7 mm per hour, but your like rainfall for last hour will be only 3 mm per hour, which means what, we should not include this. Okay. Whenever there is a value in the hydrograph which is less than your phi index, you have to exclude it in the next trial. In the first trial, I have included all of the rainfall intensities, but in the next trial, when you go for next trial, what you need to do is that you have to exclude the value or the intensity which is less than the phi index which you calculated. Okay, so the phi index value is 7 mm per hour. Now you can see in all of these intensities, your 6th hour intensity is less than the phi index, so I'll exclude this and I'll solve it in the second trial. Okay, so in the second trial, what I have done, I have included all these first 5 hour values. I have neglected this third. Okay, then I have deducted with the runoff depth and divided by the total duration, which is 6 hours. Now it has given me that the phi index is 6.5. I can now vouch for this phi index, which is less than all the hydrographs, all the intensities that I have included. Okay, this is how we determine the phi index. Okay, I hope this is very much clear. So if you have any doubt, you can ask me in the comment section. Okay, so the phi index is 6.5 mm per hour. Okay, so I have briefly written all the values that I calculated over here. Okay, though I have explained in the Excel sheet also. Okay. Next thing is we'll solve another problem for W index. So once after solving this will be the end of all the problems, numerical problems that are to be solved in the second module. Okay, now let us look into this next problem, which is total observed runoff volume during 6 hour storm with a uniform intensity of 1 centimeter per hour is 21.6 into 10 raised to 6 meter cube. If the area of the basin is 300 square kilometer, find the average infiltration rate for the basin. Okay, so here they have given you what is total runoff, observed runoff. Then he has given you what is the duration of storm. Then he has given you what is the intensity of rainfall. Okay, for the entire 6 hours, the intensity of rainfall is remaining same, which is 1.5 centimeter per hour. So you have to find the average rate of infiltration. So either you can write W index or phi index. You can use whichever equation you want. So here initial abstraction is not given to you. If initial abstraction is given to you, you would have used that also. Now the P value is given to you, R value is given to you. Let us look into what is that P value and R value. So the intensity of rainfall is 1.5 centimeter per hour. Duration is 6 hours. So if I multiply the intensity with the duration, I will get to know how much is the rainfall depth. So rainfall depth is 9 centimeter. So 1.5 multiplied by 6 will give you the rainfall depth. Okay, now let us determine what is the runoff depth. Because we have calculated the P value, let us calculate the R value. So for determining R value, I need to go to runoff volume. Runoff volume is given in terms of 21.6 into 10 raised to 6 cubic meters or meter cube. Okay, divided by area is there, area is 30 square kilometer. Convert this 30 square kilometer in terms of meter square by multiplying 1000 square to this. So volume divided by area will give you the runoff in terms of depth, which is in terms of meter. If you multiply 100 to it, you will get to know how much is runoff in terms of centimeter. Okay, now you determine P value, you know how much is R value, you can calculate how much is average infiltration, which is P minus R divided by T. T is how much? 6. So like this you can calculate how much is the average infiltration, which is 0.3 centimeter per hour. Okay, this is it. This is how you solve the problems of infiltration. Okay, so if you find any doubt, or if you find any problem that I haven't solved, you can send me that in Google Classroom, so that we can solve that problem also. Okay, from next video onwards we are going towards the third module, which is determining the runoff. We'll discuss about the runoff in the next video. Thank you.